This is the one for today. These are next week. So we got a bunch of capacitors with a battery. They asked for what's the equivalent capacitance between A and B. They tell us that this capacitance here is 1 microfarad, and then what's the voltage across C, and then what is the charge on the 2 microfarad capacitor. Okay, so we're going to do our little technique, and so the first thing we want to do is draw the circuit. And I am not looking at you guys anymore. I'm on Blackboard. There we go. I'm back. One on the sheet. So okay. Now I'm going to go in and we're going to give these names. 24. Okay. And so the names are going to be C1, C2, C3 kind of stuff. So nothing really crazy here, but you can call them Fred, George, and Barney for all I care. But I can call them capacitor 1 is 1 microfarad, and then this C I'm going to make capacitor 2. It's also 1 microfarad. And then let me go ahead and make this one capacitor 3, and it's the 2 microfarads, and then this will be capacitor 4 is 4 microfarads. There we go. All right. So we're going to find everything. Okay. So we're going to reduce it down to a single capacitor, single equivalent capacitor, and then we're going to work backwards through the pictures in order to find all the charges and all the voltages on each capacitor. And then having done that, we pretty much found everything. We can answer any question they want. Okay. But what do you see first? We need to find a simple series and or parallel combination of capacitors in this case. Okay, so there was maybe a 1, 3, and 4 are parallel. Let's take a look at that. So what I see are that there's a junction here. So if we head into the junction, go to 1, or we could go to 3. But the problem is that we don't rejoin because this one hits 2. So that one didn't work. Okay. And definitely the battery messes up heading to 4. So if the battery wasn't here, then from this junction we go to 1 to 3 to 4, but again we don't immediately all rejoin, and the battery messes up the 4. Okay, let's try again. What else do we see? Edward asked, do you count C4 and C3 as parallel? So here's the junction. You go to 3, you go to 4, but again, because of the battery, that messes up the rejoining, without anything else, So that one's not. All right. Peyton says 1 and 2 are in series. Okay. And so if we trace through here, I usually come out of the high voltage terminal on the battery. And then we hit this junction, and then I could go to C1, and then right after that, we go to C2. So these are indeed sequential. They are series. So if I were to draw my little circle around C1 and C2, then you'll notice it cuts it once on the way in and once on the way out. Those are series, just like Peyton said. So let's find our equivalent capacitance for those two series capacitors, the C1 and 2. Okay. And so I'm going to do 1 over C12 is equal to 1 over C1 plus 1 over C2. Because in series, they do that funny reciprocal adding. Okay. And so then this will give me 1 over 1 plus 1 over 1, which is not really a very interesting calculator process, but let's practice it anyways. And what you'll see is it's going to be smaller than the smallest one, which is a 1. Not smaller than the smallest one divided by 2, by how many, which is 2, so it's between half and 1. And since they're identical, it's the half. I mean, you can see it. This is 1 plus 1 is 2. Take the reciprocal, that's 1/2. So, I mean, that's what we're going to get. So my C12 is equal to 0.50, and these were in microfarads. So 1/2. Okay. Everybody good with this? Did you get to practice the little buttons and the flips, even though it wasn't a good one? I guess I could have changed the C2 value to be some other number, and we would have been, it'd been more fun, I guess. I don't know. All right. Then the next step is we shall redraw. So between here and here, we're going to put in this C12 equivalent capacitance. This is our, 0.5 microfarads. This is my capacitor 3, which is 2 microfarads, and this is capacitor 4, which is 4 microfarads. All right. Now what do we see? That Peyton didn't answer everything already. Yes. So I have my junction here. Peyton was correct, by the way. And it goes to either 1, 2, or to 3, and then we rejoin. And so from this junction to that junction, we split. Nothing else happens and rejoin. So this is indeed parallel. So I see 1, 2, and 3. You go once on the way into this junction, once on the way out of that junction. And so in parallel, the capacitances will add. And so I get C123 is C12 plus C3. And so this is 0.5 microfarads plus 2 microfarads gives us that C123 is 2.5 microfarads. Okay. And then we're going to redraw. And anywhere between, here and there, let's put it right here. We can have our C123. There we go, great. Now what do we see? Yes, they're series. Very common that it, will go back and forth like that. Unless you there was an extra parallel you didn't include or something, or an extra series we didn't include. It usually goes series to parallel to series to parallel to series to parallel. It's very, very common. Okay. Or unless you have multiple areas in the circuit, that might not do the back and forth like this. All right, but these are indeed in sequential. They're in series. You go in, you hit the 1, 2, 3. Out of here, you hit the 4. No option to go anywhere else. So those are series. We draw our little circle. It's only cut twice. And so then we do that again, that reciprocal adding. So 1 over C 1, 2, 3, 4 is 1 over C 1, 2, 3 plus 1 over C 4. So this is 1 over 2.5 plus 1 over 4. Now this one will be good to practice with our calculators. Yay. So we know the answer will be smaller than the 2.5, but not smaller than 2.5 divided by how many, which is 2. So it's between 1.25 and 2.5. Okay. So what do we get for our 1, 2, 3, 4? So we're going to do 2.5 reciprocal button plus 4 reciprocal equals reciprocal equals 1.5. And anywhere from here to here, put in our C1, 2, 3, 4 capacitance, 1.54 microfarads, 24 volts. And so then what's going to happen is the battery is going to keep putting charge onto that capacitor until the voltage here is the 24 volts. So we're going to go until, voltage 1, 2, 3, 4 is our 24 volts. Now I know the voltage in the capacitor on this green equivalent capacitance, so we can calculate the charge by using the capacitance equation. So Q1, 2, 3, 4 is C1, 2, 3, 4, voltage 1, 2, 3, 4. And so then this is our 1.54 microfarads times our 24 volts will give me a charge of so many microcoulombs. 36 something, 30. Well, if it was 24 and 1.5, it would be 36. So plus this 0.4 makes it, 36.96. There it is. Okay. So now we know the charge, the voltage, and my capacitance on the green equivalent capacitance. It came from the green circle, which are organized in series. And what's the same in series? Is it the charge or the voltage is the same in series? It's charge. So this 36.96 microcoulombs is the charge on 4, and that is the charge on 1, 2, 3. Okay, so let's put those in. So then my Q4 is this 36.96 microcoulombs, and my charge 1, 2, 3 is 36.96 microcoulombs. All right, now we got the charge and the capacitance on each, so we can use the capacitor equation to get the voltages. Okay, so let's do that. So then I'm going to do my voltage 1, 2, 3 is my Q 1, 2, 3 over the capacitance 1, 2, 3. Q is equal to CV. Yes, that's good. So my Qs are the 36.96 microcoulombs, and then the capacitance here is 2.5 microfarads, and the micro will cancel, and we will get so many volts, some fraction of the 24. 14.78. Starting from the battery, when we get to the first junction, we couldn't choose to go towards C3 first. You can, but it doesn't help, because C3 is not in series with C4 because of this extra line here. C3 and C4 are not in parallel, so you can, but it doesn't get you anywhere. You can't draw your circle, so it isn't cut 3 times. So that's only cut twice. This one, there's only one way in, and that was the 1, 2 or series. There was no other option for starting anywhere else. Sometimes you get other options in circuits, but this one didn't have that. Okay. Everything else doesn't work. You get everything else has an option to do something else, to go somewhere else or whatever on your way to finishing the parallel or the series or the whatnots. Okay. Let's get our voltage 4. Maybe I'll put it here. So this is the charge on 4 over the capacitance on 4. So this is our 36.96 microcoulombs over our 4 microfarads. The micros will cancel. We should get the rest of the voltage. So this gives me what? A 9.24. Yeah. And when we add these up, we should add back up to my voltage 123, which is 24 volts. And we get what? 24.02. So slight runoff. Doesn't look too bad at the moment. Okay. If you don't like it, we need to carry extra digits to prevent that. But we're doing all right at the moment. So if it's something I'm going to grade, it wouldn't be an issue. But the issue is, of course, always with the computer going, are you within your 1 or 2% of the actual answer with no round off error? So that's what you got to worry about. Now, if they asked about capacitor 4, we are good to go. I know the charge, I know the voltage, I can get energies, I can get anything you want. But if they ask about any of the other ones, then we're not done yet. So I'm going to take this blue equivalent capacitance, C123, came from this blue circle, and in the blue circle, they were oriented in parallel, split and rejoin. What's the same in parallel? Voltages are the same. So that means my voltage on 1, 2, 3, this 14.78, is the voltage on 3 and is the voltage on 1, 2. 14.78 volts. Voltage 3, 14.78 volts. Okay. Now we know the voltage and the capacitance on each one, so we can get the charges. So let's go ahead and get the charge on 1, 2 is Q is equal to C times V. So this is our 0.50 microfarads times my 14.78 volts was going to give me so many, microcoulombs. And then charge 3, capacitance 3 times our voltage 3. Capacitance 3 was 2 microfarads, and my voltage was that 14.78 volts. And so twice that is what? 28, 29, 4, 5, 6. And halving this is 7.39. Now, in parallel, the charges add. So if I add this one plus that one, I should go back to this 1, 2, 3 charge. And yeah, we're pretty much there. I get 36.9, but then I think I get 5. That's not bad. Small round off. Now, one more step. Are we doing all right? Okay. It'll be a good one to practice over the weekend. Okay. Green equivalent C12 goes from the green circle, which were in series. And what's the same in series? Yes. And it's always nice that the videos you can just rewatch and pause and stuff. Yep. Charges are all the same. So my Q12 is the charge on 1, and that is the charge on 2. And so then that's my 7.39 microcoulombs, 7.39 microcoulombs. And then from this, we can get our voltages. Now, the thing is that since these two are identical, then it's going to just evenly split the voltage. I mean, that's the answer. I mean, but we can go through the calculation, because what if they aren't the same? Then you just keep doing the calculations. I know the Q, I know the C, I can get the V. And so then our voltage 1 is charge 1 over capacitance 1, which is 7.39 microcoulombs divided by my 1 microfarad gives me 7.39 volts. And then my voltage on 2 gives me my charge 2 over capacitance 2, which is 7.39 microcoulombs over 1 microfarad gives me 7.39 volts. 7.39 plus 7.39 should add back up to my 14.78, and that one does. So, all right, now, what'd they ask? Well, let's go look and see what they asked. Part A asked, what's the equivalent capacitance between points A and B? Well, that's here. So, see, 1, 2, 3, 4 was 1.54 microfarads. That's the answer to A. It was right here. What is the voltage across C? Well, their C was my C2. And so the voltage there is 7.39 volts. What is the charge on the 2 microfarad capacitor? That one was my C3, so just need Q3, and Q3 is here. 29.56 microcoulombs. And there we go.